The student asked how to solve question 13 on homework 1.2. The problem asks to solve the equation by the graph. The left-hand side of this equation is of a line, and the right-hand side is a quadratic, which has a parabola for a graph. Notice that we just have one parabola graphed on each graph. So we're not looking for a point of intersection of the line and the parabola. So how can we solve it? If we bring the terms on the left-hand side over to the right-hand side of the equation, we have a quadratic equation in ax squared plus bx plus c form, set equal to 0. We can solve this equation if we can identify the right graph and see where it crosses the x-axis. We now have x squared minus 2x minus 5 equals 0. We know that the leading coefficient is 1, so since it's greater than 0, the parabola opens up, and we can eliminate these two choices. Let's look closely at the two remaining choices. Remember that the constant term c in a quadratic equation in ax squared plus bx plus c form is the y-intercept, or where the parabola crosses the y-axis. Zooming in, it looks like these both cross the y-axis at minus 5, but one parabola is shifted right and one is shifted left. This brings to mind transformations. Aha! Let's put this in transformation form by completing the square. We will take half of the coefficient b, which would be 1, and create quantity x minus 1 squared. When I replace x squared minus 2x with quantity x minus 1 squared, I added a positive 1, so I need to subtract a positive 1 to keep the original equation. This gives me quantity x minus 1 squared minus 6. Since I have x minus 1 in my transformation form of my quadratic, I know I must shift right. Therefore, my answer is option A.